Let's start. Just started the recording. So, hi everybody. Thanks for joining us for the second session of this Victor short course. So, thanks for everybody that was here last week. Um, and I don't know, we didn't get any feedback or comments or questions yet on the Slack channel. So I guess maybe you guys didn't really have time to explore the hub, or if you did, you didn't have any questions. So maybe a good sign for us. But please don't hesitate to put anything on the Slack channel or ask questions during that time here during the class time in the chat, or raise your hand and then ask a question. Please don't hesitate to do that. I mean, this class is really for you to get more familiar with the Victor platform. So we really want you to really want to make sure that you guys learn and enjoy working with the platform. Um, Right. So today, the session is going to focus on digital elevation models, what we call DEMs, and raster tools. And we're going to show you how to use Victor to get a DEM from a database, any DEM you want almost. You can see there's some restrictions, but it's a pretty wide range of resources we have already there. So get the DEM and then import it into your workspace and do some processing on this DEM, work with the DEM, and use the tools that we have available to manipulate raster data. So I guess most of you have already used digital elevation models, so plan to use digital elevation models. Um, that's a tool that is widely uh, used for any numerical model, so that's why it's pretty important. And that's something that we have available on Victor. So we wanted to start with that to show you what you can do already to start a project related to any raster data or digital elevation models you would need. So this is an interactive session, so please log into Victor and open a session on Victor using the Jupyter Hub. If some of you still have trouble to log into Victor, please let us know. It's very important that everybody is able to perform the activities at the same time as we do them. So try to log in right now. If there's any trouble, let me know on the chat, and we're gonna be able to help you. Um, and then I guess Sam is gonna take over to lead these
Yep.
activities.
Yep. Um, sure. I'm ready to start unless you have any final comments. Alright, great. You should be able to see my screen now.
Yep.
Perfect. Okay. So, uh, let me start from where everyone else will be because we're going to copy a specific notebook. So once you're in your home directory, we're all going to go into the shared folder, and then education, and then into, I'll pull this out, this spring course, so USF Comp Folk Spring 2026. And then we have this week 2 intro folder, which we're going to use. And what I want what I want everyone to do in this case is take this file called short course. You can right click, copy, and then you can just click this folder. Let's go back to the home directory and paste. And then just double click that notebook to open it up. I'll give you 30 seconds to do that, and then we can start going through. All right. As I start going through this, at some point, I think Sophia can post a PDF or a couple of slides we have, which is just a kind of more step-by-step teaching or like written out explanation, whereas I'm going to do this all more verbally. So if you want both open, you can, but I'll also just be talking through. So um, we're just going to start saying, why are we using DEMs and what formats do we use for them? So uh, a lot of the time it comes down to either an ASCII file or GeoTIFF. Uh, GeoTIFFs are binary encoded, so we can't actually read them like normal text. But for an ASCII, we can read that. For example, if I go into the shared folder again and just pick one of these DEMs, let's say this klima.asc. So that's an ASCII file, but we can read all the data. This is the elevation data right there. And it says number of rows, number of columns, and then the lower left corner, the size of the cell, and then if there is no data for whatever reason, what that will be replaced with. But if I try to open, let's say this Hawaii DM, it take a second, and you can see it thinks of it as an image, but we can't read it by default. With ASCII files, they by default don't have any georeferencing or mapping. They'll need external files. So like in this case of the Kalima file, you can see on my screen there's a PRJ file. And we see, oh, okay, it's giving some reference. It's UTM zone 13 north. Yeah, like whether we're in which side of the meridian we're on. We're using transverse Mercator and so on. Whereas with a GeoTIFF file, that's all encapsulated within the file. I would say if you need to check things manually, an ASCII file is better. But if you have a large amount of data or high resolution, GeoTIFF is generally better. It's more compact. It'll take up less space. But in that case, those are the two we mainly use. So just to start, I'm going to import the Python libraries we use. What we're going to be using today is a couple different things, but mainly some functions from the PyVector or the victor.py library. This point probably has about 24 functions, from plotting flows to pulling DMs, which is what we're doing here, to some like other quality of life things like converting like resolution or standardizing it between two files. And you can take a look in the shared libraries directory if you want to actually just look at the code itself. But once we're done with that, we run this cell. You can either press the play button, or what I prefer to do is doing shift and then enter. Just please stay on the keyboard, not have to move my mouse all around. So what we can do here, and what I'd like everyone to do, is just run these few cells. And I'll go through and explain before we get through all of that. So in this notebook, at least, we're giving the user an option between TIFF or GeoTIFF or an ASCII file. In this case, we're requesting a TIFF. We're looking for a name of the output file, and also let me just double check all of this. um, the name of the volcano that we're looking for. This should say the name of the volcano rather than the name of the output file. And then there are a variety of different data sets. There is SRTM, there's Copernicus, there's a NASA worldwide set. There's a few different ones. In this case, we'll just stick with SRTM. But right now, there's, I would say, about 4 different both 30-meter and 90-meter resolution worldwide maps, which are great for kind of rough approximations for lava flows. If you need anything more accurate, then you probably want to go down to 10 or 5 meters. But generally, 30-meter is a very good kind of first pass. And then what we're also going to do is set the extent of the region of interest. So we're going to say we want 11 kilometers east and west, and then 8,000 north and south. So I can run this cell, and those store all those variables. Yes.
Yeah. Can you show us the list of different DEMs and that we can? I think it was in another notebook. You added before.
Yes.
Sorry about that, but just so just for the users to know what they have to enter in the data set. Because
this is So this one is. So this notebook, this is more. This is a less guided notebook, which is why I wanted to do this one. But this notebook shows the different options.
Okay.
Like this one's very similar, but it basically just it doesn't explain as much for the user. I'm trying to kind of this one's meant to be more for the short course. But yes, so I can highlight these. So we have SRTM, ALOS, NASA, Copernicus. There's also one for bathymetry. But yeah, so there's quite a variety of options. And then I'll actually show you the website in a little bit. The reason why we do everything the way we're doing it here is because excuse me. The reason why we take this structure is because this downloads it directly to the Victor platform, to your directory. You can go through website and then upload it from your computer onto the Victor hub, but we're trying to make everything centralized here. Anyway, what we do next is we can go to this cell and start running things. This is one of the functions. It's search volcano. We're using the Smithsonian database. We're trying to get the volcano latitude and longitude. And then we're functionally what we're doing here is converting the latitude and longitude to UTM coordinates to meters, and then adding that east and west extent, or east-west, like the kind of extent that we want around the volcano rather than just the exact point as shown. So if I run this, right now it just shows the latitude and longitude, but if we want, I can look at volcano and you can see it has the name, latitude, longitude, and elevation. And what we'll go back to do in a second is, let's say I want to look at Mount Hood. I can run here. And then if I run this again, you can see, in this case, it actually has 2 because Hoodoo also includes Hood, but it allows users to basically look at any, put in a name and get any volcanoes that correspond with that. So for now, let's keep that with Pinatubo. That's great.
Yeah, so this is just to clarify, this is any volcano name from the Smithsonian Institution, the Global Volcanism Program. So you can go in there and then any name that is actually in that database, you can actually type it in the workflow, and that's should be able to find it.
You can also download it right here.
Okay.
It's just an Excel file currently, but it is updated fairly regularly. Okay, so this is just some housekeeping. This one we can keep running. So no particular comments on that. And then I'm realizing now that I didn't set up the bounds correctly right here, but for the time being, what we can do is just run this file how it is. So we have another Victor function called download DEM, and we're taking latitude and longitude and basically saying in for about 0.05, which is about 5 kilometers in either direction, or in any cardinal direction we want to download DEM. And this is still hard coded. So let's actually change this. If you remember, we had up here, we have the data set and the output format. So we can change that. I'd encourage you to do this along with me just so you get your kind of first taste of changing code. And then now if I run this, oops, and I spell it correctly, if we give it a moment, so it's a decently big file, so we're going to give it one. It'll take a second, but there we go. It's now downloaded. Right now we just have the name like this. So you should be able to set a name itself. I think it's just another parameter like name equals. I have to double check that, but we save them as default, just DM the coordinates, the data set, and then the date you downloaded it. This for now we can actually skip this cell. There's another function that takes in, instead of taking in a latitude and longitude, takes in the UTM coordinates, but also requires the user to specify the hemisphere and the UTM zone. Otherwise, it can't pinpoint it. And then we also, so we can skip this cell in the meantime, but we can go on to the download DM USGS. So there is for the continental US and I think parts of Alaska and Hawaii, there is a 10 meter, 3 meter, and 1 meter resolution. So that's another option for anyone who's doing research on or in the US. We can run this one too. These are hard-coded values for, not remember this, might be Mount St. Helens, it might be another, but you see here, it's just downloaded just as quick. And this was an ASCII file instead of this one, which was a GeoTIFF. But what we can do is, let's see, in this case, we're going to copy the name of this file. For now, the best way is to just manually copy it, and then we're going to change the file name to that and run this, which is okay. I'm realizing now that we can actually ignore this cell in the meantime. So for now, let's ignore this cell and continue on. And then for the
there's a message on the chat that says that somebody still have an error about latitude and longitude variables. Do you know where that may come from?
Um, oh, they probably need to run this cell.
Okay.
Yeah, unfortunately, it doesn't let me see the chat when I'm sharing my screen.
Yeah, no problem. I can let you know.
Uh, so let me double check if this works. Okay. In this case, I'd have to change the coordinates, so I'll delete that for now. In the meantime, let's ignore this cell. Uh, but what we can do is I'm going to take a brief look at these in a second, but you can copy the name of the DEM and use the victory.plotDEM function. And you can see right here, it immediately with a nice hillshade gives you Pinatubo. Might be a little hard to see, but there's the caldera, and you can see the kind of the edge of the crater and the slope off. For the DM to UTM, what I realize is that it does have to be an ASCII file. That's an ASCII file for the input, so that's just something I need to fix in the function, but that's just development for you. And then, so yeah, if ideally you should be able to take any of the DM download as, and then take these file names and then throw them right in victor.plotdem and get a nice raster. I'll take a brief aside and talk about open topography, which is a really great resource. So let's go to data. So centers on the US, it has most data for the US, but there's a great interactive map. So for instance, let's zoom in over here and then just select many particular regions. So we've selected this box. This is just in Northern Oregon, but there's a huge variety. So we have the global DEMs, which I was talking about before, the NASA DM, ALOS, SRTM, and then we actually have some high resolution in this area. So there's point cloud data from the Oregon Department of Geology. There's point clouds from, I guess, a 2018 fly through. And then there's coastal LiDAR, which again, you need to specifically apply for access. But actually, I think the account we have associated with Victor should have access to all of these. So it's a very, it's actually, I'll finish with this, and then we even have a community contributed like geomorphology or morphometric layer data set. So open topography by itself has this tool. We just looped in with some code through Victor, but we find it a very good resource. We that as I said, is both good for first passes, but also testing with all of our, all of our lava flow models. If I let's see, maybe we can find something in Italy because it is worldwide. Just see. Sometimes it may just have.
Yeah, you can do on Naples.
Mhm. See, community contributed. Okay, this is also geomorphology. Yeah. It's possible it just doesn't have it. It is still, it's a U.S. focused product, or it's run by, I think, a U.S. university. So it may be missing. But what you can do also, as it is open topography, it's part of this open source push. Um, there is opportunity for community contribution. So if you have data for an area that is often desired, and instead of emailing it or sharing through Box or something, or Google Drive, you can put it on here and make it looped in, so any user who is interested can use it. And then what I also have is, if you're interested in the kind of the more code side, is there's an API I have, which is what we're using, and that's what we use to pull all the raster data. I think they've updated with a few things. They have actually they have DSMs and DTMs now for the world, for global data sets, which actually may be interesting for areas with I'm not exactly sure how they do this, but it might be with buildings, with forests. So this might be an interesting data set that you all might be interested in. Whereas then there's also one that I mentioned for the USGS, 1 meter, 10 meter, 30 meter. And then this one is less important. This just actually is a catalog search. It doesn't do any downloading. It just shows you what there is available. Continuing on, I'm going to highlight a couple of libraries, and we will have to change the name of this file to the one that we were just working with Pinatubo, but I will get to that in just a moment. So yeah, let's talk about Raster.io first. So we have these rasters, and in the past, a lot of what people would use is something like GDAL. There's, at this point, dozens of different commands to warp, reproject, and then edit in little different ways. But Raster.io and some of the other packages I'm going to talk about are make it all a lot more interactive and a lot more visual and easier to work with. So in this case, yeah, Raster.io gives you much better access to geospatial raster data. In this example right here, you can see we just they just open the file. It's called an example.tiff, as similar to what we're using. It pulls the data set mask immediately. We can extract feature shapes if there's any. So if that does that very quickly, and then I immediately, in just one line of code here, can transform from whatever the original coordinates reference system is to the CRS-84. We don't have to go into this too much, and I'm going to show a kind of more useful library that packages it with another more mathematical library. But if I go back here and we pop back the name of the DEM, we can run this and immediately get basically the all the data from that geotiff in well packaged into a two-dimensional array, like a matrix functionally. And what I can do here, I could, if I actually want to look at the values, I can type that in. It's going to give me a second, and it's just showing some of the edge values because there's 360 by 360 values, so we're tens of thousands or 100,000 different values. But what we can do here is also take slices. So what I'll also highlight real quick is Xarray, which we're combining those for both Xarray and Raster IO into this library called Rio Xarray, and it allows us to basically use this one command and use both libraries very quickly and fairly painlessly. Let's see. So, for instance, we can do just take any given slice. So let's say we want to do we have to do the first band, and then so now we have all. So at the first at the top y value. So this is the 0th row, because with Python we start indexing at 0 for anyone who doesn't know. So 0th or first row in the DEM with one y value and all the x values. So we can check all the values here. If we give that a second, gives us a nice slice. I could do dot x. And then it shows us all the coordinate values. So you can see the increments we're making from 120.3 degrees all the way to 0.399. We do the same for y, but we just have one value here. And then another nice thing we can do is directly plot it. So this is a slightly different color map and overall approach, but it's still, we go back up here and look at that, compare the two, pretty much the same thing. I mean, it should be the same thing, but visually pretty much the same thing. But what I really appreciate about Xarray and things like this is that it's very quick and easy to index and take these slices of. So if you only need a subsection, if you only want, let's say, you can even just take parts in the middle. I want, I want lines and rows 30 to 40 on both. And we could even do that. Suddenly, we have a little cutout of the DEM to work with. And then you could even export that to its own raster. It's just very kind of quick and compact. Let me see. Importantly, this is actually something I should have mentioned, is there's attributes. There's a lot of layers of data that you can provide. And if I can find a good example, I might be able to. I'll come back to it in a second. But the key part of it, of Rio Xarray and Xarray as a whole, is that it has all these attributes and all these different dimensions, which allows you to index it both by number, by name. And it's just really helpful, especially for something like a time series analysis. And then I'm not sure if I have too much to say immediately on the rest of this notebook. What we could go on to, though, maybe I'll take a brief aside and let Sylvan talk about kind of some details that I may have missed, is if we go back to the not workflows, education folder, there is this take home, and in this,
so just before you go through the take home, there's a question in the chat that asks, is there a library to fix DEMs, like filling gaps or interpolating elevation values? Yes, there are. So maybe
yeah,
Sam, you want to start, and then if you miss something, I can add.
to interpolate.
Yeah, filling gaps and interpolating elevation values.
That should be able to be done with like let me double within Rio X-ray. Like if yeah, right here, they actually even have a usage example for it. So in this, and even in this case, they're using a netcdf, and you can see this is the data is always standardized into an X-array data array, but still has those coordinates. In this case, it has some extra data. It has the CRS as an attribute, the resolution, but so we're loading that in, and then there's literally an interpolate the NA or like non-existent data. So immediately you can see these values that were previously not available right in there. So yeah, that blank area filled in, and that's functionally one line of code.
Yeah, you
And
can also
then
do that with Quantum GIS. So if
absolutely.
you don't really like line of codes, you go into the desktop and then you launch Quantum GIS, QGIS, and then you can go into Raster, and then you will have a lot of things there where you can fill the no data values, for example, and you can do some interpolation there as well, using mostly the GDAL libraries. So very similar to that, yeah.
Yeah, I mean, all in all, under the hood, a lot of these are using kind of the same base mechanisms. But if you're on my end, you come from a more computational background. You want to use this line of code. If you're if you're very comfortable with GIS software, you go to QGIS and use the interpolation option there. And then I guess if you're old school and you want to do it through a terminal with like GDAL translate, GDAL interpolate, you can also do that. I don't think Savannah or I would support you, but you can do what you want.
Yeah, no, for sure. That's the great thing with Victor. You can, if you want to use Linux codes, you can use Linux codes. If you want to use notebook, Jupyter notebooks, you can use Jupyter notebooks. Or if you want to use interactive software, you still have QGIS on the desktop to do that. So it's very flexible. There is a question about why do we need a ASCII file and not a GeoTIFF to download high resolution DEMs from the US. But I guess you said that just a function you
No,
need to have.
sorry. No, that can be ASCII or GeoTIFF. It was the helper function I have that converts a file in lat long to UTM that needs to be an ASCII, and I just need to fix that. The actual USGS one should work with either type.
Mm-hmm.
Yeah, so I can start on this. The idea of this, I think last year, was to have it more as a take home, but moving pretty quickly, and you can honestly run through this in a variety of ways. So I'm going to copy this one as well over to home directory. Was that? And the beginning is very similar. But we are adding a few extra little options. And what we're going to do in the end, I don't think I have it here, is we're going to functionally take a slice, get the slope of it, and then make a file that could be used with PyFlogo, which is a 1D like lava flow channel model based on Flogo, which I think initially was an Excel like formula, but this is the modern version that I can't currently remember who the creator was, the developer was, but I'll make sure to find them in a moment. Anyway, as with the other notebooks, we load the first, we load the libraries as needed. And at this point, any of you can pick whichever volcano you want. In this case, let's say I want Etna, and make sure you spell it right. Now, what we're doing here is this, pulls latitude, longitude, gets the UTM values, and then there is the proj4 notation, which some of you may have used before. This is just making sure we get the right coordinates when we want to reproject. It's one of many ways. There are options in Raster.io to, let's see, like for georeferencing to change that. But in this case, I'm just showing one other option using PyProj and like proj4 notation. But I can run this, and now it gives us the UTM easting and northing of I don't know. And then in this case, we can just call it etna.tiff. And what we're doing in this case, because by default, the DEMs are downloaded as WGS84, so they are purely latitude and longitude and don't have any local UTM coordinates. So if I run this and then run this file as well, give it a second, it's going to download the file. You'll see a pop-up saying it's been downloaded. We're reprojecting it, and then it will plot in just a moment. Let's see. Unless it doesn't like something. Let me try it with this without the file name. Okay. So I'm realizing there may be a small problem that won't allow us to do this right now. So the way I have it set up is the download DEM function uses our personal API key for downloading DEMs. So everyone is using the same one, and it might have been rate limited. So that's why it's giving me a 401. It should normally not have a problem because there'll only be a handful of people using this at any time. But when we have everyone downloading the file at the same time, the Open Topography sees that as a bit suspicious, and they pause allowing us to download. So I might have to come back to this. Yeah, no, that's because of the scale of Victor, it's okay for me to use our API key, but it's not good practice in the long run. And if we had thousands of users, we would ask them to bring your own. But we don't want to make everyone do that. So I might have to stop for now.
Okay, it's okay if if you guys do it like not all today, but you can do it during the week. I mean, you would have 1 week to do this homework, so you can always try it later if that doesn't work. If you get the same error as Sam just got.
Yeah. So let's see. In the meantime,
I can, if you want, I can show how to do it on QGIS.
Yeah, that would be great. I think that's actually a great use of kind of wrapping up our time, showing how to do it through Victor on QGIS.
Yeah. Can you see my screen?
Yes.
All right. So you can just launch the desktop, and then you can just double click on the Quantum GIS and open it, and it should look like that. So you can add a raster first. If you go into layers here, and then you say add layer, and then add raster layer. So for example, I'm going to take a DEM from Fuego that I already have here. It's in ASCII. I'm gonna add it. Okay. So now I have it displayed here. What I can do, I can also do an hillshade to that quickly. So you go into raster analysis hillshade. Then you just run it. And then it looks a little bit better now. We can better see the topography. And then, by the way, everything that Sam mentioned in terms of raster processing and analysis, you can have it. Mostly everything is on QGIS, especially the last versions are really good for that. So if you go on processing here and then you click on toolbox, you're gonna get that processing toolbox here on the right side, and you can see you got all the different tools that you can use, in QGIS in terms of raster or vector. So it's really good, and you're going to see that a lot of things are already in there for doing, fitting the data, getting the slope of the DEM, etc., etc. And so if I remember well, you need to go on View and then Elevation Profile here. And then you can interactively draw an elevation profile from your DEM. So if you click on Capture Curve, I think, and then you can just, let's say, I want a profile of the volcano. So I'm going to click here, go through the summit of Fuego, and on the other side. And then I can get the elevation profile here. So yeah, you can see the coordinates are seen in degrees, so you can change the coordinates if you want as well by clicking here, and then browsing through the UTM coordinates if you want to get the corrected coordinates in your profile. I'm not gonna do it here, but that's basically what you can do. So yeah, so that's the interactive way of doing it using a GIS software, and you can do all this in Victor. You can import your own DEM into Victor on your home directory, and then you can load it here on QGIS, and then do some analysis with using all the tools that are available on QGIS. So that's really great. It's all open source and ready to use. Right. So you still want to show the notebook, maybe some for people to be able to work on it during the week. If you can just like explain a little bit what they need to do.
Sure.
Even if it's you cannot download the DEM right now.
Mm-hmm. Yeah. So for this take-home assignment, go back to the top. You can pick any volcano you want. This is first spot. You're gonna need to change the name. The second spot is this will be empty. Put a file name in there, and then yeah. So as you can see right here, so once that works normally, what we'll do, it'll plot. We'll see that. That'll be great. And then actually some notes here. So yeah, you'll be able to open the file and like I showed you with RioX array. And then in this case, we basically take a slice. So right here, exactly what I said. We're just taking from the caldera to a kilometer east. We're taking a slice, and we can do it with this command. And then yeah, again, this is more just to kind of get a feel for it. We take that slice and then kind of take it again, and then basically say, let's get just the y value that's closest to the UTM north. We need to do this because unless the values line up exactly, it will throw an error otherwise. You can do some plotting, which will show there of the profile, which will just be, a 1D line or points. But then what I need to do, because we'll be using PyFlogo, is calculate the slopes along this profile. So in all these cells, what you see is just a bit of subtraction, a bit of trigonometry, and anyway, once you get through that, you'll see a plot with the calculation of the slope. And then from there, there's a bunch of properly kind of setting up the text file for PyFlogo, which I think we have on the schedule. I just can't remember what week, but it will be. You'll have a nice file set up for then to be ingested by PyFlogo. Initially, this notebook was empty, and we were asking users, or I think the some attendants to a workshop to fill it out. But we added some solution notes here, so you can kind of get some context to why everything is done in the way we did it, or in the way I wrote the code. So
can you just explain a little bit what NumPy and Panda are?
NumPy and Pandas are two libraries for working with like multidimensional data. So if I go it's, let's see. Multidimensional array structures. Yeah, so it's all for this. You can get the shape. If you have any type of matrix or multidimensional calculation you need to do, let's see, it just goes on and on and on. But you can reshape quickly, indexing, slicing, broadcasting, matrices. But it does things very quick. Like in normal Python, you have some things you can, like some basic things you can do with a list, or but with NumPy, everything's super quick, even in multi dimensions. And then Pandas does a lot of similar things. They kind of can work with each other, but it's especially good at working with Excel files, CSVs, stuff like that, and taking slices there. It's great for data analysis. So like, let's go to getting started. Or right here.
So data for tables, maybe, and things like that.
Yeah, it's data for tables. That's yeah, like NumPy is all centered around that multidimensional array, and Pandas is kind of all centered around data tables. So right. Let me see if I can find. But you can also, it has a lot of kind of nice built-in things. So once you load in an Excel file, it can give you a bunch of data, of each column. And then this is just one small example. But yeah, those are two of the many different libraries. So I'll just like run through these quickly. This is for reprojecting. This is for multidimensional arrays. This is just a plotting library. This is for system internals. These two I talked about earlier. CartoPy is for georeferencing and making sure that the
systems,
the reference systems, and like the way sometimes functions will look for the CRS in a very specific format. So that helps with this. Pandas I just talked about. And then Victor is this in-house library we made, and then UTM is another library that has like 4 functions, and they're purely just for going lat long to UTM and back, and they're super quick. And then if you want to see a whole list and get overwhelmed, and give this, let's say, 10 seconds, there are literally hundreds of libraries in Victor that go anywhere from ZAR, which is another kind of high dimension large data storage like parsing library, to we have Vesicle and Volphi, which are we'll talk about towards the end of the course, which are geochemistry codes. We have I don't know, so many different things. We have like TK, it's like tkinter for kind of making GUIs, for making user interfaces. It just goes on and on, but this is a, believe it or not, non-exhaustive list of all of the packages
I just
we
wanted
have.
to add that, if these are the libraries we're using, but if some of you are, experts in Python and digital elevation models or raster data, and all the libraries that are really useful, please, share it with us, whether on the Slack channel or on the chat here. Share with us your experience of using other libraries that what we're using, because maybe there's something that we didn't think of. That's also, this course is also for sharing this kind of knowledge if you have it.
Mm-hmm. Yeah, what we want to do in the long term is now and in the long term is keep an open channel between us and the community. If there's something that isn't working or isn't included on the platform, tell us so we can add it or fix it. If there's something that we are doing well and you think it's not explained or it's not well advertised, tell us, like say you should advertise this more. Like we want to know what you like, what you don't like. We want to make this platform as good as possible for as many of you as possible. That's, I think, all I have.
Yeah, so we need to wrap it up. So Sam, so they need to run this to work with this workflow, the take home notebook that is available on the short course folder. And do you know if they can, once they finish with it, can they submit it somewhere?
Right now, not yet.
Okay, all right. So what I would suggest is that right now you just keep it with you until we solve the issue of exchanging folders and files as a group on Victor. And so if you can try to work on it during this week or even the week after, if we haven't solved the problem, there's no strict deadline for assignments. So have a try at it. Download your own DEM. Try to get this elevation profile working and the slope, and then let us know how it goes on the Slack channel. And there is also office hours that starts now. So that's going to be on the Zoom link. Maybe Sophia, if you can share the Zoom link on the chat right now, so then people who wanna go to the office hours right after this class, they can do it. Yeah, thank you. So we start the office hours until this week, and then otherwise see you next week for the next session. Thank you, everybody, and have a good weekend. See you next week.
Thank you.